This production is brought to you by the University of Edinburgh.
Afternoon, everyone. I'm Dr. James Hopgood. I think I saw most of you on Monday at the sort of reception lunch. And at the back is Professor John Thompson. So you can wave to John. And John's going to come up and sort of chip in later on when we get onto sort of personal tutor matters. So I know that you've already had a couple of induction talks generally about the school. So today's talk is specifically about the MSc programme. And if any of you have come on a virtual visiting day, you might have heard some of this online previously. But basically the talk is going to last about half an hour, and I'm going to start off talking about the course programme and what to expect, and then I'm going to move on, and this is where John will come and join us, and we'll talk about the personal tutor issues and things that you need to be very aware of about your studies. So the first thing about the MSc programme, so you've all chosen this for whatever reason, so something must have inspired you either in a previous degree or perhaps if you've been into industry for a year or so, but something inspired you to want to do an MSc programme in signal processing and communications. So the programme is split about 50-50. This is a research slide that I've taken, actually plagiarised from a colleague from a grant, but actually summarises a number of things about signal processing and also communications. And you can start off pretty much on, if we look on the right hand side, one thing to note about signal processing and communication is that we're dealing with measurements that come from sensors. So whatever the device, be it a mobile phone with an antenna receiving signals which are RF radio waves, RF signals that are transmitted, whatever we deal with, we're always taking real world signals and we're sensing them. So as I said, be an antenna, or it could be a microphone. So I'm trying to record this, but I've got a microphone, or it could be a camera, or it could be medical imaging modality. So it could be an ultrasound scanner, MRI scanner, or it could be something like an active detection system, such as radar or sonar, and they can be passive as well. There's a whole variety of sensing. So I've listed a few of those there. Electro-optic basically refers to things like cameras, infrared cameras, anything which involves an optical element. Now, we sort of kind of address sensing. We try and remember that that's what signal processing is about as we do the course. But really, we're sort of slightly lower down the chain. But after you've had your sensor, then we have to try and acquire the signal somehow. So that means being able to sample the signal. So at an undergraduate level, you would have considered things like Nyquist sampling theorem, how fast do you sample a signal, and what's the best way of doing that, and all the aspects involved with practical sampling. And once you've got the sampled signal, we're in the digital domain. So throughout this course, we do digital communications and digital signal processing. We're not really in the analog world very much. So once you've got the signal processing, that's where you try and take the signals and you extract information from it. So if it's a communication signal, you're trying to recover the data that was transmitted at the transmitter. If it's signal processing, it might be you're trying to enhance a signal, you're trying to enhance an audio recording or a video recording, or it might be you're trying to detect a target. So if it's radar, then if there are actual targets, you're trying to relate, for example, the position of an aircraft to the measurements that you've got. So, I mean, I think an interesting case was, for example, if you have when aircraft go missing, and the issue of the aircraft that got lost in the ocean, and they had very few data points upon which to try and track where the object was from. But you could consider that a bit of a signal processing and communications aspect as well. So this is pretty much where we sit. So we sit in this third box here. That's what most of the course covers. There's high level inference as well. So once you've extracted information, for example, where is the aircraft and where is it going, at a top level you can go one stage further and try and address what's the intent of that aircraft. So it's not just about extracting numbers. And this sort of high-level inference is covered a little bit throughout the course as an application area. This is something that you would, if you're designing a product in a company, you would have to sort of go to. But this also borders with informatics and computer science. But remember, it's worth noting where we sit in this, what I'd call a signal processing chain. So the goal of this MSc is to provide you with basically the fundamentals of signal processing communications. So we're going to develop the theoretical foundations as well as addressing some sort of what we call advanced topics. So semester 1 is going to be mostly about theoretical foundations. You'll be revising some material from your undergraduate course as well as a significant amount of new material. Just because I noticed someone taking pictures of this, these slides will be available on the ETO hub at the end, and I might even put the recording online if it works out okay. So don't worry about trying to take too many notes or remember things, this will be available to you. So first semester is about theoretical foundations. When you go into the second semester, well, two things will happen. One is you'll have courses which rather unimaginatively have a word advanced in front of them. So you've got some courses like advanced coding techniques, advanced wireless communications, advanced concepts in signal processing. And that's basically, they will cover both, they will go into more detail about some very well-known material, but they will also scratch the surface of some sort of cutting-edge research as well. You also, of course, do the MSc research project, and that is another way of touching on some hot research topics in signal processing. So the objectives of the program are, as I say, to identify basic theoretical principles of signal processing communications, but also to try and teach you the scientific method. So this is particularly true in research project. So basically, how do you, if you want to design an algorithm, how do you systematically test it and do this in a scientific manner, as opposed to hacking code? So that's an important aspect. And I think one key thing we try and convey is that we can't teach you everything there is to know, well, everything that is known about signal processing communications in a single one-year course, one-year program. So we're going to teach you what we think is important, and a primary thing that we want to try and teach you is teach you enough so that you can go away and do further study on your own, and that you're at a level where you can either go off and study a specific topic in detail at a PhD level, or you could go and work in a company, and if you're working on an unfamiliar topic, you've got enough background to be able to go and read a fairly advanced textbook on the subject and to learn more material. Okay, so that's the goals of the program. So who's going to be teaching you this material? There'll be, if anyone's got any burning questions, feel free to ask as I go along, but there'll be a big chance for discussion at the end. Anyway, who's going to be teaching you this course? Well, hope you recognise both me and John, although me and John are, or John and me rather, or John and I, are very guilty of using photos that are perhaps about 10 years out of date. I haven't changed much, but maybe John has though. We should really update these, but anyway. I'm the program director, and which means that I've got basically an overview. I do a lot of admin regarding making sure that the program runs smoothly. But I'm also a personal tutor for the MSc course, so half of you are one of my personal tutees. And John Thompson is the Director of Discipline. So John is basically, well, from the perspective of teaching within a school, from the perspective of electrical engineering teaching, John is well, he's called a Dodd, but he's more like a god because he's got complete control over all teaching aspects with regards to electrical engineering. So that's what is called by a Director of Discipline. And John is also a personal tutor. As we'll see, we each teach a course. So John teaches advanced coding techniques, is it, John? Well, anyway, I think John teaches advanced coding techniques. And I teach two courses, one called Statistical Signal Processing and one called random variables and estimation theory. The other two, I would say, key people who you may come into, well, you will come into contact with, well, may and will, you will come in contact a lot with Farm Ratnajar, because, and he's now a professor, so I need to update that, but his primary role is that he's project coordinator. So I'll talk about the projects a bit more in a while, but later this semester you'll be allocated an MSc project, and Farm will both give you a talk to explain the full details of that process, and so you'll be liaising with him, giving Farm your choices of which project to choose and so forth. Farm is also the academic misconduct officer, so you don't want to come across Farm in that capacity. Okay, so that can come about basically through plagiarism. So when you write any coursework, which can cover anything from a MATLAB lab submission through to the pre-dissertation project and the main research project, if you have plagiarized a significant amount of material, and significant means more than about, well, it's hard to quantify, but if more than 10 or 20% of the material is extracted in a non-scholarly way, if it's done in a non-academic manner, you can be basically you can fall under the plagiarism rules, and that is academic misconduct, and so if that happened, you would Farm would be involved. But let's hope that we come back to plagiarism. The simplest way there are very simple rules for avoiding plagiarism. Okay. The key one is just enjoy the subject and do the work yourself. Okay, that's one good thing. Professor Bernie Mulgrew, sorry, before I move on, Farm Ratnajar teaches you he teaches you a course called Array Processing and MIMO Systems, and he also teaches you a course called Advanced Wireless Communications. So he teaches you 2 courses as well. Professor Bernie Mulgrew is the chair of the board of examiners. So when we've marked all your exam papers and we've got all the marks, we have an exam board, and Professor Mulgrew's role is to make sure that all those procedures are airtight and that they're strictly adhered to, and Bernie's role is to ensure that the marks that you get through the assessment are awarded as fairly and accurately as possible. Okay, so it's Bernie's interest to make sure that you're being fairly represented. Okay, so there are a number of other academic staff who you're going to meet, and in fact I have a couple of pictures I haven't put on because I didn't have them when the slides were ready, but they teach different courses. So I don't know if you've come across Dr. Dave Lawrenson yet. He's involved in admissions, but Dave Lawrenson will teach a first semester course called Discrete Time Signal Analysis. Professor Mike Davies teaches a course in Advanced Concepts in Signal Processing. Dr. Javier Escudero teaches a course in Image Processing. Dr. Majid Safari teaches the course Digital Communications Fundamentals. I've got a list of all these courses in a while. And now the other staff who are here, Dr. Nick Polidrides, Javinjar, and Professor Howard Haas, all supervise MSc projects. Out of interest, how many of you recognise Harold from somewhere? Because so obviously we've got this Li-Fi centre in the University of Edinburgh, which is using LED, basically lights, to try and communicate data rather than using Wi-Fi. And Howard Haas gave a TED talk a few years ago, and it was quite a popular talk. So it's sort of, if you're interested in a hot topic in communication theory, then basically visible light communications is a very hot topic, and Harold is one of the leading researchers in the world on this. And as I say, there are a couple of other staff who you also meet who supervise MSc projects, and you'll meet those in due course. So the program structure is you might have already been told this because all our MScs have the same structure, and you might have had a general overview. But there are 2 key elements. There's the taught courses, which are primarily lecture-based, although there's a lab course. and the main project, the research project. So the talk courses start on Monday. So in fact, I think if the timetable hasn't changed, then you'll get me first at, I think, 10 o'clock Monday morning. And we are going to start with probability random variables estimation theory. And you've got 11 weeks for the first semester, and you have 6 talk courses, each worth 10 credits each. So now one of those courses is a MATLAB lab, and so that takes out 1. So basically, come December, you're going to have 5 exams, each lasting 2 hours, I think. So we'll come back to that in a moment, because that's we're middle of September. So in 3 months' time, you're going to be sitting 10 hours worth of exams. And what we're going to emphasize after I finish just giving an overview is we need to get you preparing for that straight away. Right? So bear that in mind. Second semester is a little bit more, it's a bit more relaxed, but possibly more challenging in terms of the technical content. And the reason it's sort of more relaxed is only because it starts in the middle of January and goes on till the middle of, or the end of March, but your exams aren't really until May. So you've got a bigger breathing space. You've got 3 or 4 weeks to prepare for those exams. However, you also in the second semester are doing something called the pre-dissertation project. So basically at the end of this semester we allocate you the research project, and in semester 2 you work on this project for approximately 1 day per week. And that contributes towards this so-called pre-dissertation. And the idea of that is to give you an opportunity to do a literature review and to do some preliminary work on your main research project, such that after the exams finish, which at the end of May, you can do the full project, the main project as we call it, that you're ready to go into that and work on it full time and be fully prepared and do as much as you can. And that project carries on until the middle of August and is worth 60 credits, which is a third of a course, because the total credits is 180. Okay, so I'll talk about this. The project basically ends at the end of August, and then all being well, later in November and early December, you will then graduate, and some of you hopefully will be around or be able to come back, and you can get together and graduate. Okay, so I can't remember what this is. This is by the way, this is some sort of time frequency part. I think this is a synthetic aperture radar signal. It's a way of, it's a radar detection, but it's from a moving aircraft. It's quite a recent technique which people have made work very well. Okay, so I'm just going to list the courses, just so you're familiar with what they are. So for this program, there's no options. You all do the same courses. Well, I think pretty much all of you will do the same courses. We don't have anyone. The only reason for not doing the same courses is if you happen to have been one of our undergraduates already, but I don't recognise any of you as being one of our undergraduates, so you're all doing these courses. So you do what we call the Digital Signal Processing Laboratory, which is kind of what I've been calling the MATLAB laboratory. It's actually using MATLAB to investigate signal processing algorithms. So it's not just about learning how to use MATLAB, it's about using MATLAB as a tool to try and understand better some basic signal processing. So that runs, I think, on Tuesday mornings for about 3 hours and has various submissions. Whilst Mike Davies, I think, encourages you to kind of work together, he's also very, very strict on too much copying. So because these labs are computer-based, it's very easy. You can just email each other your code, but Mike has various strategies for detecting any plagiarism on that aspect. So what I would say from the outset is if you want to do well in this MSc, you need to understand material yourself. And to understand something well, you actually have to do it yourself. So whilst it's okay to get ideas from your friends, don't copy. Okay, because it's not going to do you very well at the end, and I might come back to that again in a while. There's an image processing course, which Javier teaches digital comms fundamentals, discrete time signal analysis, and the 2 courses I teach, probability, random variables, estimation theory, statistical signal processing. And the second semester, you've got 5 taught courses, array processing methods and MIMO systems, adaptive signal processing, advanced concepts and signal processing, advanced coding techniques, advanced wireless communications, and a pre-dissertation project. So what are we hoping that you can get at the end of this? So there are, these are the we want you to go away with an MSc degree. So you might have seen this already. You can get a distinction in the MSc, which comes if you basically get a distinction in both the project and an average distinction mark across all the taught courses. So you can study this later. Basically, to get a distinction, it means you have to do well, not just in exams, but you also have to be able to do research well as well. So those are contributions. Something that is new this year is that there's something called a merit, which basically you get a merit if you're between 60 and 69%. And that's if you get a merit in both the project and in the courses as well. Okay, now, sometimes, and we're going to talk about this in depth in a moment, sometimes things go wrong. And for whatever reason, it might be out with your control, or sometimes it can be within your control and you've just lost interest. But sometimes things can go wrong. And we don't really want you to go away home with nothing. So let's say that something goes wrong and you don't pass the MSc. Pass the MSc, you need a minimum of 50% across a certain number of credits, and 50% in a project. Basically, you need to pass most things. If for some reason this doesn't work out, then you can get, there are 2 other degrees which you can get, which are a diploma, and that basically, you'd get a diploma if you pass most of your courses, most of your MSc courses. Well, you need to pass 80 credits. So there are 120 credits of taught courses. You need to be able to pass 2/3 of those with a pass mark of 40%. And so if you do the taught courses, but for some reason don't progress to the project, you can come out with a diploma. Or if you do very well in the taught courses, but you actually get below 50% in a project, then you might end up with a diploma as well. So, but a diploma is still a very respectable degree to come out with. So if something does go wrong, then I think, a diploma is well respected. If things get very bad, such as, for example, you have to leave after the first semester and you haven't passed that many exams, then you may get a certificate of postgraduate education. Basically, if these are, if we detect that there's a chance you're not going to get an MSc degree, and that there's a risk of getting either of these, your personal tutors will talk to you. So we'll be able to talk to you in more depth about those. I think where we want, from today, what you're aiming for is an MSc degree. And the question is, from your perspective, I think, is are you going to get a distinction or not? Because I imagine that's why most of you are here. Okay, so that's what I'd sort of focus on there. So I suppose moving slightly onto the sort of pastoral side, I put this slide up, and the upshot is that the exams are sooner than you think. Okay, so you're in Freshers Week this week. So as I said on Monday, the priority is to make sure you're settled in, you're matriculated and everything is sorted out. If you were to do one thing this week that could save your bacon substantially, is go and register with a doctor. So you've probably been told this a lot. So this time last year, in the first semester, and it wasn't just last year, it's happened occasionally, we had a couple of students, through circumstances beyond their control, they were ill and they missed an exam. They just literally couldn't. Initially, they couldn't. They were throwing up everywhere. It was just. It can happen to all of us. You wake up and there's no way you could sit an exam, and so they missed the exam. Now I think we had a couple of students who did this, but we had one student who was registered with a doctor and was able to, later in the day, not feeling very well, managed to call to the doctor and say, look, I've been very ill all day. and they were registered with a doctor, and the doctor said, okay, I can write you a medical note to say that you were ill. Now with that medical note, you can then apply for something called special circumstances. And special circumstances will basically address the situation that there was a circumstance beyond your control which meant that you weren't able to have a fair assessment. So that one was okay. That student worked out okay. But there's another student who missed the exam, wasn't registered with a doctor, couldn't go and get a medical note, and their exam mark was therefore set as absent and 0 with no recourse. Basically, that was a very serious situation. There was nothing the exam board could do. By essentially getting an absent, or effectively 0, your average is dropped. Well, you're not passing the credits, and there's no compensation we can do. So you might think, I've never been ill in my life, and even if I was, I don't want anyone else to know, and I'm going to crawl to the exam, and it'll all be fine. Okay. We cannot stress significantly enough how, if that happens to you, like if you miss an exam or something goes horribly wrong, you can't study, maybe you haven't been able to, maybe you fell off your bike and you've been in pain for 2 weeks before the exam. If there's no medical evidence or there's no evidence about this situation, we cannot help you, because we cannot distinguish. Well, we cannot distinguish between something. Someone said, well, I missed an exam, I was ill. Well, how do we know? Like, we have to be seen to be fair to all students, and the only way to be fair is for everyone to produce sufficient evidence. So, register with a doctor. I don't know if you want to say anything to reiterate that point. So, as I say, last year was scary, and in fact, the net result, I think, of a couple of students missing, was it 1 exam or 2 exams? I think they missed 1 exam, but they had failed a couple of courses already. It essentially meant that 1 exam that they missed meant they could not get an MSc degree, and they left with a diploma. So they ended up with this, because an MSc, I'm missing it on here, but the MSc, you've got to pass 80 credits at 50%. And I think they'd already failed a couple of exams. They missed that 1 exam. Essentially their mark was 0. That brought their average below 50%. And they could not get an MSc, and they could not go on to the project. And it was a bit of an awful situation. So, on the back of this, week 1 starts next week, and then your lectures finish basically early December, and then about 1 week later you start the first of your 5 exams. And there's no there's very little revision time available to you. So, we've seen over the past, so this MSc course has been running for 10 years, and each year we see that some students don't really sort of get into their studies until about week 5 or 6, and that's too late. By that point you're getting way behind on material, because you're getting new material come along. So you need to plan for your studies, work out when you're going to study each week, and stick to a plan that starts on basically week 1 onwards. Week 1 is a bit easier because you might not have very many sort of tutorial questions to do, but week 1 you might want to sort of make sure that you read all the lecture notes that you've covered, and just make sure that you're ready to launch into it when all the material starts coming your way. So do things like, for example, all your lectures are in the morning, so you'll be free after 1 o'clock most days. So work out what times are you going to study. Are you going to study 2 till 5, 2 till 6, maybe in the evenings as well. Try and come up with a study plan that works from week 2, and if you're not studying from week 2 for sure onwards, be worried, because these exams come up very, very rapidly. So if at any stage you're feeling falling behind, discuss it with your personal tutor. So John and I, we're going to do, we'll talk about this in more detail, but in a few weeks we will invite you all for a personal tutor meeting, and that will be a good time. We'll discuss with each of you how the studies are going. But even after that, if you feel that you're falling behind, talk to your personal tutor. But you can also talk to your course lecturer, because he might be able to advise you on what material to prioritise. So if you're one of my personal tutors, things are easy because I'm teaching 2 other courses. I can sort of tell you where you are. And if you have any special circumstances, so special circumstances involve anything out with your control. So it could be illness, or it could be bereavement, or it could be family, severe family issues. Come and talk to your personal tutor. Now, most of our students, one of the things is, because you all come from, students come from different backgrounds, and some students are more open about if they've got a situation which is affecting their studies. Some students are more open about going to talk to their personal tutors. Others are a little bit more, they will keep it to themselves. And depending, sort of how you brought up, people deal with it in different ways. Because this is your studies, and because you've got exams in 3 months, I would advise try and go and speak to your personal tutor, and it might be worth mentioning to them that there's some serious situation going on that is affecting your studies, and you can have a discussion, and they might be able to advise whether to put special circumstance in or not. But we've had students who have basically not raised issues until it's too late because they didn't want to discuss it with anyone. And obviously that's your right to do as well, but just be aware that if you don't discuss it with anyone, then there's nothing we can do to help you. The thing I should also mention is, of course, you've got the student support team in the teaching office as well, who you might be able to go and speak to. Okay, so the special circumstances, I think you've probably heard this from a variety of means before, but the Board of Examiners can take into account these special circumstances. So a typical situation might be if you've missed an exam but through illness and that's documented, then we might be able to let you progress to the project even though you haven't got enough credits to do so. So it might be we would say the effect of missing that one exam is so disproportionate to the effect of not progressing to the project that the Board of Examiners can basically discard that mark. Or other situations, for example, what the Board of Examiners can do is, if a special circumstance sort of says, well, okay, that person was at the exam, but was feeling very, very ill, then their exam mark might not reflect what their performance might have been otherwise. And let's say that your exam mark, you come out with 48%, which would normally be a fail for that course. Well, the exam board could say, well, we're going to be lenient at the borderline and allow you to pass that course and contribute to your credits. So all of that, but you have to do this through your personal tutor, so either John or myself, and you want to ideally raise that as soon as you possibly can. Look, I think one thing I want to say is ideally no one has a special circumstance, but there are 33 students in the class, and the probability that one of you is in a situation that's going to affect your study is quite high, to be honest, because it's just life. So I hope generally everyone has a really happy semester. So yeah. Okay. Do you want to say anything more on a personal tutor side, John? Okay. I'm only going to touch on this because I think the ETO cover it more. But as a staff student liaison committee, have any of you heard of the staff student liaison committee? Have you been spoken to about it? No. Right, well, briefly, this is a committee where I think it's 2 of you. Yeah, 2 of you. Well, 2 from each MSc that we run will be elected by the rest of the class to represent your views as a cohort. And try and convey those views to the academic staff and also to the teaching support staff. So, if for example, there's a problem with the lecture theatres or the lecturer's not delivering enough material for you, or who knows what the issues are. From your perspective, you've got an opportunity to try and convey your concerns to the staff and to both the academic staff and to the teaching staff. So you'll be invited to nominate, or you'll be invited to nominate 2 representatives in the next week or 2, I believe. So if any of you quite enjoy a little bit student politics or just doing something like this, then make yourself available. Okay, and there's a meeting once per semester, so actually it's only 2 meetings to go to, and they only last about an hour and a half at most. And yep, that's it. Okay. One thing that I'm going to mention, because I had quite a few questions on Monday about this, is further study. So you might already be thinking, I mean, if you've come to do an MSc, you probably have a plan for what you're doing after the MSc. So that might be, you might go back to your home country and find a job, or you might sort of already be thinking, I want to do a PhD. So I think my first suggestion, if you're interested in doing a PhD, then feel free to contact your personal tutor, so either John or myself. So I had questions, should you contact the academic staff directly? And I think at the moment, for this semester at least, I would say no. I would approach your personal tutor and send them a copy of your CV as well. So at the moment, usually it's very hard to identify who the strongest students are to do PhDs. So PhDs are usually limited places, and so we can't offer the whole class a PhD place. It wouldn't be feasible. But at the moment, it's hard to identify who the best students are, even based on your undergraduate results. So usually, to be honest, what we're usually waiting for is to see what your results are, at least at the end of the first semester, even more so probably towards at least halfway through the second semester, when your project supervisor can comment on how your research project is going, but also more likely at the end of the second semester exam marks. So we need information to be able to sort of identify people. Now, all that said, there is a sort of China scholarship funding scheme that some of you might have heard of. So this is for people from China. And the deadline of that is the end of January. And you probably will see, you may see emails circulated about this. But what I'd say at this point is that it's a very highly competitive scheme, because usually the applicants are from outside or from China directly, rather than students already in the UK studying. And in fact, you'll be okay if you studied in the UK already for, I think, 2 years. You may or may not be eligible. There's various eligibility criteria, but it's very highly competitive. And I would say that in order for your application to be successful, you would need to have publications already. That's pretty much the only way to distinguish candidates without an MSc level degree. So if you had, for example, an undergraduate project and you managed to get a couple of IEEE publications out of that, you might, at this point, stand a chance of the China scholarship scheme. Okay, but if that is the case, you will have to be ready to react very quickly at the end of January 2016. Okay, but it's a very, very competitive scheme. So what more relevantly, each year the Institute of Digital Communications, which is where all the academic staff are from, usually award a PhD to the top few students in the MSc. So last year I think we have 2 PhD students from the class who have stayed on, and I think we could have had 3, but one of them went off to London instead. But the upshot is you have to be near the top of the class, and I would typically say you need to have an excellent performance throughout the MSc, and you need to really get a distinction. A solid distinction is much better, and it has to be a distinction in both exams and in the research. So if you got 98% in all your exams, but only 51% in your project, that might not be a great academic record. However, all that being said, because the way I presented it, it sounds hard to get a PhD place, and it is. A few of you will probably get a PhD place, but it is hard. But all that said, many of our past students have got PhD places at many other leading institutions across the world. So last year, I was told, we had one student went off to EPFL in Switzerland. We've got one at Queen Mary University in London. Other students have gone to Denmark. And a lot of our students get PhD places, not necessarily at Edinburgh, but I think in each of these cases, academic excellence is absolutely crucial. So you need to get good results. Okay. All right. I think I'll a couple more quick slides, and when we have a discussion. So we've got, and this is a bit. Oh, right. Okay. So let's just check what you need to do in order to progress to the MSc research project. So there are 120 credits of taught courses. So in order to go to the project phase, you have to pass at least 80 of those. Maybe I'll rephrase this. You have 12 taught courses, including your pre-dissertation. You have to pass 8 of those with a mark of at least 50%. Okay, so that's the minimum. But you also have to get an average of at least 50% across all 120 credits of study. So you have to sit all 12 courses, and overall you need an average of 50%, and you need 50% in at least 8 courses. So in other words, what you can't do, see if I can get this right, is you can't have 100% in 6 courses and 0% in the other 6 courses, because that would average out at 50% on average, but you haven't got 50% in 8 courses. Anyway, it's a little bit. It basically means you've got to be good across the board. So if you came out of semester 1 with 100%, full stop, you've got to still work semester 2. Okay, here's the upshot. So basically, you've got to be consistently good across virtually all the courses. So that's what that means. And if you don't meet each of those criteria, you won't be able to progress to the project. Okay, have you got that? Because no? All right. My advice is pass all your courses, okay, with 50%. Okay. Now, that progression is determined at the end of a second semester exam board, which is basically late May or early June. But from your perspective, again, if there's concern, probably your personal tutor you'd have probably had a discussion with them about it. So you go into the MSc project. So I thought, I'll give you a very quick discussion about the project. So the projects are proposed in semester 1. It's not that early. Probably you'll get a list of projects will be circulated to you maybe the middle of October. So about week 6 or 7, or you'll get a list of projects. Now these list of projects are anonymous. They're about 100 words long. You'll probably get a choice of about 50 projects. 100-word description, which tells you a little bit about what each project could be about, and a title. And it also gives you general subject areas, like, for example, is it wireless communications, or is it statistical signal processing, or medical imaging, or whatever. But the one thing you don't know is you don't know who the project supervisor is, and that's because we don't want you choosing a project with your favourite lecturer. Right? And the reason for that is you've only seen half of the staff before this semester anyway, so we don't want you to be biased by picking your favourite academic person. You pick the project you're interested in, and if you find a project that you're interested in and you're excited by, that will mean that you probably are more motivated, and it will mean you'll work harder, and that's better for the academic supervisor as well, because it's much easier to supervise a well-motivated and interested student than it is to supervise someone who is kind of not really very interested. So it's a matchmaking exercise to match you to your favourite project. Now, it might be that, so what you do is you pick your 3 to 6 top projects. So you list in order which projects you want to do. Now, it might be that all of you want to do the same project, but one person can't supervise 35 students. So therefore, we have a system which matches as many choices as possible whilst maintaining the supervisor load. Anyway, Farm will discuss that more with you. So the key thing from your perspective is that the project allocation doesn't really start until the middle of October, and you'll be making decisions. You'll probably make a choice sometime middle of November, and then the projects are allocated late November, and you'll meet your supervisor early in December, which happens to coincide with when the exams start. So that's a very busy period. So. Okay, I think it's probably because I've gone on quite bit longer than I probably expected. So, does anyone have any questions at the moment?
Yeah, some of the projects title maybe depends on some of the material presented in the second semester. So you won't be motivated as if you will talk the second semester. How can I manage that?
Do you mean like if there's some projects where you don't really know?
Advanced coding, for example.
Yeah. How do you know? I think most of the project descriptions are a bit more sort of slightly higher level than that, rather than sort of perhaps addressing a particular, they discuss sort of general maybe application areas and what kind of techniques will be used. So it might be that, so if you've got a project in advanced wireless communications, it would discuss what a major problem is and whether it's a hot topic and what techniques could be used to do it. But it doesn't matter that you haven't necessarily done all the background reading in that subject or studying. So just go for the projects that sound interesting and that sound fun.
100%.
Yeah. Okay. So just very briefly, the question was, what's the main form of assessment for most of the courses? Most of the courses are 100% exam. Some of them might be like 90% exam with a very small amount of maybe a class test or something like that. But predominantly all the courses are 100% exam based.
So you have only one final exam?
Oh, but just one exam per course.
There is no midterm.
You have exams in December and exams in May. Yeah.
This production is copyright the University of Edinburgh.